and good morning everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to my session of Antennas CTQ series. We are into Antennas CTQ series and this is part 15. Just confirm the video and audio once, dear. Yes, ma'am. Yes, ma'am. Good morning, everyone. Just confirm the video and audio once. Before we start the session, let me introduce myself. I am G Chaitanya Reddy, having 15 plus years of experience teaching, guiding and mentoring students preparing for competitive exams including GATE and ESE. I work as motivational speaker pan India from the past 12 years, expert in field theory and communications. And this is the official link where you can join us on Telegram. The advantage of joining us on Telegram is that you get a personal level support from all the team members of GATE Conqueror. And the good news to all the GATE Conqueror followers is that 4 new educators recently joined us. Four new educators recently joined us, dear. Four new educators recently. Sorry. Yeah. As you all know, 4 very talented, experienced faculties joined. We are geared up to finish GATE 2023, ESE 2023 comprehensively. There will be a lot of difference the way we cover the syllabi, especially on GATE Conqueror channel. Because in true sense, we'll finish the syllabi comprehensively, suitable for both GATE and ESE. And I had been shouldered the responsibility of finishing EMFT, for ECE people, for both GATE and ESE. And also, I'll be handling EMF for electrical. EMF is a small part of EMFT with some small changes. Ditto for both GATE and ESE. I will be finishing communications, very important communications for EC, for both GATE and ESE, with some small changes. And also finishing communications for electrical for ESE. I've been shouldered the responsibility of finishing advanced communications. This is true for EC, for engineering services. Of these things, dear, what we had already covered on GATE Conqueror channel, I'll explain the later half, along with some wonderful questions, concept 3 questions on antennas. Unacademy offers 2 paid platforms. One is Plus subscription, other is Iconic. In Plus subscription, you got to have FaceTime of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, we have all these features of Plus subscription. Along with that, we have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts within 1 hour, preparatory study material, personalized test analysis, study booster sessions, and a customized study planner. We strongly believe that a study planner designed for a student does not suit for another. So, your personal coach will be helping you out in designing your study planner or your customized study planner. And whether you take Plus subscription or Iconic subscription, I recommend you to go for a no-cost EMI. The total cost will be divided by number of months. Very much student-friendly, available from 6 months subscription onwards. You can use our team code KNR10, which gives additional 10% off. Iconic subscription, it 1:1 live mentoring, improving your chances of getting a top rank. These are the features of GATE and ESE Iconic subscription. We'll have 1:1 live mentoring, online study material, priority in Ask a Doubt, live doubt solving sessions, study booster sessions, priority in live classes using raise a hand, open house with educators, community learning, and all benefits of plus. Definitely with an iconic subscription, you take your preparation to the next level. The best study material is here, dear. The good thing is free physical notes. The notes which is curated by India's top educators, having comprehensive syllabus coverage, solved examples to build problem solving skills. It is available for EC, electrical, mechanical, civil and computer science. And these physical notes, which will be so much of help for you, is available for 1 year and above subscriptions on Gate Iconic. This is Unacademy Lite subscription, which will help you out in cracking the Gate 2023 and 2024. Lite subscription is nothing but a mix of topic and subject-wise mock test will be provided here. You'll get access to structured test series, detailed solutions and performance analysis will be given. I always tell you this. For succeeding in competitive exams, practice is a very important point. The more you practice, the more is the probability that you succeed in competitive exams. The fact is that you need to leave that particular situation beforehand. You need to experience that particular situation, the environment of a GATE exam, the environment of an engineering services exam. You need to experience it beforehand, which is possible only through mock test. Once you write minimum of 40 mock tests, you will be in that comfort zone that you can manage the stress and time very easily. To subscribe, use our team code KNR10. Unacademy Ultra Combat, which is today 11 a.m. You can enroll now using the code KNR10. This will perform well, or the top rankers of the combat will stand a chance to get 100% scholarship and also exciting gadgets. You stand a chance to win a Mac Airbook, iPad, iPhone 11, Samsung Watch, JBL speaker, and lucky participants to win Amazon gift vouchers. These questions of the live quiz are curated by India's topmost faculties so that you feel the real standard of the examination. I always recommend my students not to write a mock test which is substandard. Writing a substandard mock test, you'll always leave in the false illusion. The examination is very easy. If you want to live up to the reality, you try to write standardized mock test, standardized live quiz. As this quiz questions have been curated India's topmost faculties, you will experience some very good quality questions so that you understand your level of preparation. So everyone, do not miss today's Ultra Combat at 11 a.m. As I told you, it's a live quiz competition with 30 questions and 60 minutes. Today at 11 a.m. By writing Ultra Combats like this, you to stand a chance to top GATE and ESE like your fellow students has done. So all the best to all the students for today's combat. To subscribe, use our team code KNR10. Unacademy Ask a Doubt feature, which is now available on app and website. At a go, you can ask 3 doubts. Just a second here, I'm trying to hide the video. And also, you'll get the solution in your preferred language. It is also very easy to ask your doubt. Just click, crop and submit. So we are here to clear your doubts, my dear friends. Try to utilize this opportunity and your doubts will be cleared within 24 hours. It's also a very easy method to post your doubt. 3 doubts you can keep in a single queue. So all the best, dear. We are here to clear your doubts. If you have any doubt in your preparation journey, have any queries about your subscriptions, want to know about the latest offers, you can contact our counselor, and this is a number where you need to contact all 8 5s. These are the special class features, which includes interactive live classes, polls for the learners, raise hand option. You never miss a class. Once the notification is on, you can download the lecture notes. Once the class is completed, you can access any time and anywhere. The next special class will be on Monday, 11:30 a.m. where I'll be discussing about the 10 mantras for success. Every week, we start 7 or 8 new batches. These are the new batches, dear. Ascend, GATE 2024. Started on April 20 for electrical. Explain bilingual. You can use our code KNR10 to enroll yourself. For these batches. Ascend GATE 2024 for ECE, Explain Bilingual. Evolve GATE 2023 for Electrical, Explained Bilingual started April 20. Evolve Gate 2023 for ECE Explained Bilingual. As I told you, you can use our code KNR10 to avail extra 10% off. We are into antennas, concept through question series, and as I told you, on this channel we are determined to cover EMFT comprehensively and get yourself prepared for GATE and ESE 2023. The EMFT subject contains 5 modules. In which module 1 elements of EMF theory, it's common for both ECE and electrical. Electrical, it is complete syllabus. For ECE, it is 1 module out of 5. We covered this for both GATE and ESE. Covering this for both GATE and ESE, created a playlist which is available the GATE Conqueror channel. This playlist containing 40 videos and 50 hours. It contains 40 videos and 50 hours of content. As I told you, what is the difference between our channel and other YouTube channels? The difference is, you take on any other YouTube channel elements of EMF theory, maximum number of hours will not be more than 10. Against that, what we got here is 50 hours. You can just imagine how much of practice questions we might have done and how many derivations we might have done, how many concepts we might have covered for GATE and ESE. Against the 10 hours of general playlist that will be created on most of the wide channels. On our channel, on the GATE Conqueror channel, you have this wonderful playlist of 50 hours of content only on elements of EMF theory, complete syllabus for electrical, for EMF, and they can prepare for both GATE and ESE. And module 1 for ECE, covering both GATE and ESE. We covered all the topics, all the concepts, all the derivations useful for engineering services. All the concepts useful for GATE. Solved all previous year questions from both GATE and ESE. And also done so many practice questions along with the previous year questions. This is a wonderful playlist here. It is available on the channel. Please go through the playlist. Useful for both EC and electrical people preparing for both GATE and ESE. Next is module 2. EM wave propagation. This is for EC. We have covered both GATE and ESE. This module 1 is done completely. There is nothing left out in this. Module 1. In module 2, we covered 90% of the syllabi. The playlist is ready for this too. Created a playlist with 15 videos and 30 hours of content. Again, not more than 6 or 7 hours of content will be available on any other channel for EM wave propagation. Already we had recorded 30 hours of content to cover only 90% of the syllabi. We'll add 6 more hours. We'll add 6 more hours to this module 2 to cover the rest of the 10%. That will become around 35 hours or 36 hours of playlist, which is again almost like 5 or 6 fold greater than what you find in any other YT channel. I personally covered all the derivations required for engineering services, all the concepts required for GATE, solved all the previous year question papers for both GATE and ESE. All the previous year questions and practice questions. Lot of practice questions are also added for this module 2. Module 3 is on transmission lines. Module 4 is on waveguides. We'll start both transmission lines and waveguides here, probably from next week. Module 5 optical fiber communication and antennas, and please go through this playlist here, which are already available on the channel. Optical fiber communication, I'll try to create a playlist. We'll take a separate series with 10 hours of content. For antennas, already created a playlist. The name antennas, Maha Marathon series. It's a very unique series where we covered all the antennas. 1 second here. We covered all the antennas, including the seven sisters. And also focus was on wave propagation. This is a very unique playlist. Covers both GATE and ESE. Generally, you'll have some 5 or 6 hours of content on antennas. But this series is special because it covers both GATE and ESE, covering the very special seven sisters concept and also covering antenna measurements. We created this playlist (18 videos), 38 hours of content. So, 3 playlists are available right now, covering more than 60% of the syllabus of EMFT, 100% of EMF. If you take EMFT, you have a playlist created you have a first playlist covering module 1, which is for 50 hours duration. Playlist 2 covering module 2, 30 hours duration. One more playlist covering module 5, 38 hours of content, making it a total of 118 hours of content. I'm ready to add 1 or 2 hours more content, making it a 220-hour playlist for EMFT. This 1 or 2 hours cover 10 hours of OFC, module 3 transmission lines, module 4 waveguides, and this 10% of EM wave propagation. I had seen many playlists, different YouTube channels. The maximum number of hours for EMFT subject completely will not cross 40 hours. That is what they provide, maximum 40 hours for the complete subject. Against that, we are providing 220 hours here. Just you can see it's almost 5 to 6 fold greater than what you have on other channels. That is why I say it is truly comprehensive. Just we don't say for namesake that it is, we are covered it comprehensively. Our hours speak the truth. And I need not add anything, am I right? The playlist is available. You can check the playlist anytime you want. Cannot manipulate and tell these numbers. These are all raw facts available on the channel. All this playlist, right now they are available on the channel. You can verify. That's the reason I say if you seriously want to prepare for GATE and ESE, the GATE Conqueror channel, our channel is a one-stop solution for that, for both EC and electrical people. Not only media, all the other faculties are also covering the syllabus comprehensively in this way. One second. So let us see what you have in this module 1. Module 1. Is elements of EMF theory. Module 1 is elements of EMF theory. Common for EC and electrical. For this we created the playlist. $40 videos and 50 hours content. Suitable for both GATE and ESE exams for electrical and ECE. What we covered here in elements of EMF theory. Divided the elements of EMF theory into 3 parts. One is basics, 2 static field theory, is time varying field theory. Under basics, we divided the basics into 2 parts. Elements of vector calculus, and coordinate system. And under elements of vector calculus, we start our discussion with the scalar quantity. What is scalar, dear? What is the scalar, dear? Yes, dear. One second. Yes, tell me how do you define the scalar? Confirm once video, dear. Video audio is clear, no? I'm just trying to verify that. Fine. Yeah, please tell me. Yes, dear. Discussed on scalar. Scalar is something which has only magnitude. And no direction. Examples: mass, time, speed, distance, voltage, current, power. And here most of the people do not understand that current is a scalar, it's not a vector. Most of the people think that current is a vector, which is not true. Current is a scalar quantity. Please go through the playlist. A detailed explanation was given. The concept. Why current is scalar? So, a detailed explanation was given here, explaining why current is scalar. Please go through this video in the playlist. You'll get a good understanding of how to define scalars, especially this topic, why current is scalar. Next is a vector quantity. It is one which has both magnitude and direction. Examples: weight, velocity, acceleration, force, torque, dipole moment, and so on. Many are there. And vector is one which has both magnitude and direction, and it obeys vector addition. This subclass, I can say here, more than 90% don't know. More than 90% of the people don't know about the subclass, that it obeys vector addition. It must obey. Every vector must obey vector addition. Next is unit vector. Unit vector always gives you the direction of the vector. It always speaks about the direction of the vector. These are fundamental quantities. Scalar, vector and unit vector. The fundamental quantities, we are given so many examples. Explained it very clearly in the playlist. Please go through it. Then we went for addition of vectors. In addition of vectors, we had seen parallelogram law, and head to tail rule. Also called as triangular law. Also called as triangular law. What is this parallelogram law? If A and B are two vectors such that it forms two arms of a parallelogram, A and B are two vectors forming two arms of a parallelogram. This parallelogram law. This is head to tail rule. What is head to tail rule here? Head to tail rule is also called as triangular law. If A and B are two vectors, what it is stating? If A and B are two vectors such that the head of A joins the tail of B, such that the head of A joins the tail of B. If this is a vector, then this is the head of the vector and this is the tail of the vector. The resultant C is equal to A plus B. Starts at tail of A and ends at head of B. Now I told you that a vector is one which is having both magnitude and direction. It must obey vector addition. Am I right? A vector is one. It's having both magnitude and direction, which obeys vector addition. What does it mean? This is a root cause to explain why current is scalar. This will explain why current is scalar. Let me explain. Now, if A and B are two vectors here, let this be IA current, this be IB, and this be IC, which is IA plus IB, according to vector addition. Here I am trying to explain you why current is scalar despite having magnitude and direction. If this is IA and this is IB, and this is IC, which is IA plus IB, the amount of current at this point is IA plus IB. If you take one more diagram, this is IA, this is IB, and if you reverse it, it is minus IC, which is minus IA minus IB. This is IA, this is IB, total current at this point is IA plus IB, total current at this point, is IA plus IB plus minus IA minus IB, total current is 0. But what kind of network it is? It is a short circuit network. What you can see is a short circuit. Tell me dear, for short circuit, how much should be current? If it is short circuit, how much is current here? Current is minimum or maximum? For short circuit, the current is minimum or maximum? Anyone? Yes. It is a short circuit. How is the current? Is it minimum or maximum? Short circuit, the current must be maximum. But how much current you got? 0. That means what? Current does not obey vector addition. This is the reason why, despite having magnitude and direction, current is a scalar. Is it clear? So that we have discussed addition of and many more things. I'm just trying to give a synopsis of this, just a rough understanding of this. Please go to the playlist. We have some wonderful examples for this also. Then we went for basic laws of vectors. Basic laws of vectors. What are basic laws of vectors, dear? What are the basic laws of vectors? commutative law, associative law, and distributive law. Let us see for addition and multiplication. Addition and multiplication. Commutative law of addition, anyone? Commutative law of addition. A and B are two vectors. A plus B is equal to B plus A. Commutative law of addition. Commutative law of multiplication, if K is a scalar, K into A is equal to A into K. Commutative law of multiplication. Next is, if A, B, C are three vectors, associative law of addition, A plus of B plus C is equal to A plus B plus C. The associative law of multiplication, if K and L are two scalars, A is a vector, K into LA is equal to K into L into A. Associative law of multiplication. This is distributive law. Distributive law of addition, if K is a scalar, A and B are two vectors, K into A plus B is equal to KA plus KB. Distributive law of addition. Can someone tell me what is distributive law of multiplication then? Distributive law of multiplication. Think and tell me distributive law of multiplication. Distributive law of multiplication. Not defined. It's frequently asked interview question. This is a frequently asked interview question. Like this, so many number of things I explained in the playlist here. You can go to the playlist. You'll get more and more understanding. Why current is scalar? This is also FAI, frequently asked interview question. This is also a frequently asked interview question. FAI or FAIQ. Like this, so many interview questions we discussed here, which has some strong basics. So these are basic laws: commutative, associative, distributive. Then we went for multiplication of vectors. Then we went for multiplication of vectors. The multiplication of vectors, cross product, vector product. One second. Let me write the dot product. Dot product, scalar product, cross product, vector product. Take dot product, a scalar product, take dot product or scalar product. A and B are two vectors. Dot product of two vectors A dot B is equal to mod A mod B cos of theta AB. But theta AB is the small angle between A and B. What does it mean? If A is a vector, B is a vector, theta AB is this small angle between A and B. This is called small angle. And this is called larger angle. Theta AB is the small angle between A and B. That's why it is necessary to mention that it is small angle. This is the formula when angle is given. Formula when angle is given. If angle is not given, again I am telling you, this is only a small synopsis. If you go through the playlist, again in-depth analysis I have done based on the theta values, their physical significance, relation with force, displacement, work done, examples, so many things. Okay, just go to the playlist here. If A is given as AX plus AY plus AZ. B is given as BX plus BY plus BZ. This is when angle is not given. A dot B is equal to AX dot AX is 1. Multiply the coefficients AX BX. AX dot AY is 0. AX dot AZ is 0. So you need not multiply. AY dot AX is 0. So it is simply element by element multiplication. AX BX plus AY BY plus AZ BZ. This is the formula when angle is not given. This is the formula when angle is given. Again the significance The physical significance, examples, lot more understanding or change of this value with respect to theta. All that I discussed in the playlist here. Please go through it. Only 15 hours. 15 hours dedicatedly I took only these basics. So in 30 or 40 minutes I can't explain all of that, am I right? So please go through. You'll get a lot more understanding. This is when angle is given. This is when angle is not given. Okay. One second here. Fine. Any doubts you can ask? So now we'll see. So now we'll see. We have seen the formulas when angle is given and angle is not given for dot product. Let us see what are the basic laws this dot product will follow. Can anyone tell me? What are the basic laws this dot product will follow? Does it obey? One second here. Okay. Does it obey commutative law? If it obeys commutative law, A dot B is equal to B dot A, and yes, it is true. It implies that dot product obeys commutative law because A dot B is equal to B dot A. Next is associative law. Does it obey associative law? If it obeys associative law, A dot B dot C is equal to A dot B dot C. Is it the case? Is it equal? Does it obey associative, anyone? Does it obey associative, anyone? Does it obey associative? Think and tell me. Just think and tell me, does it obey associative? If it does not obey, what is the reason? Does it obey associative? It does not obey associative law. Why? Once you do A is a vector, B is a vector, A dot B is a scalar. B is a vector, C is a vector, B dot C is a scalar. You cannot do dot product between a scalar and a vector. Not defined. To do dot product or cross product, we need two vectors. Therefore, writing itself is not possible like this. It's an absurd. Therefore, we can say that it does not obey associative law. Next is distributive law. Next is distributive law. What is distributive law here? Does dot product obey distributive law? A dot of B plus C is equal to A dot B plus A dot C. Yes, it is true. It obeys distributive law. Dot product obeys commutative and distributive. And does not obey associative. So that's the conclusion. You will see the cross product. Also called as a vector product because the resultant is a vector. If A and B are two vectors, A cross B, mod A mod B, sin theta AB. This is the magnitude of the cross product into AN. This is the direction. Again, dear, please go to the playlist. Very detailed explanation about this magnitude analysis. Almost like 2 hours of analysis are done on only cross product. Can't imagine, just 2 hours of analysis on this simple equation. We are done in basics. Please go to the playlist. You'll understand at what level of understanding our discussion was there. So I can't repeat all of that. That's the reason I asked you to go to the playlist. This is only a glimpse to show that what is there on our channel. So just go through the playlist, you'll understand more about this equation. In-depth analysis we have done. And this is when angle is given. What is the significance of this magnitude, what it represents, and what is this direction, how to understand this direction, and everything. Definitely, I am very sure that you learn new things if you go through it. This is when angle is given. If angle is not given, A is AX plus AY plus AZ B is Bx Ax plus By Ay plus B is that Az. Angle is not given. A cross B is equal to determinant of unit vector Ax, Ay, Az. Coefficients of the first vector Ax, Ay, Az. Coefficients of the second vector Ax, Bx, By, Bz. You determine, if you evaluate this determinant, you get the resultant of A cross B. This is when angle is not given. This is angle is given. This is when angle is given. This is when angle is not given. And again, which laws does it obey? Can anyone help me out in explaining which laws cross product will obey? Does it obey commutative law? Anyone? Does it obey commutative law? Anyone? Can anyone help me out? Does it obey commutative law? Does it obey commutative law? If it obeys commutative law, A cross B must be equal to B cross A. But is it equal? Is A cross B equal to B cross A? No, A cross B is not equal to B cross A. It is not commutative. It is not commutative. But A cross B is equal to minus B cross A. It is anti-commutative. It is anti-commutative. And here in some books it is given minus B cross A. In some books it is given minus of B cross A. Can you tell me which is correct in this? The first statement is correct or second statement is correct? If it is correct, what is the reason? Can anyone tell me? Which statement is correct? Yes, dear. Can you tell me which statement is correct? Let us see which statement is correct. A cross B is equal to minus B cross A. This is given in some books, and in some books it is given as minus of B cross A. So which is correct? We need to verify. Let us verify which is correct. A is a vector given by 2ax plus 3ay. B is a vector given by 4ax plus 2ay. A cross B. Determinant of 2 by 2 is enough because resultant will be along AZ as we know. 2, 3, 4, 2 of AZ. 4 minus 12 minus 8 AZ. A cross B is minus 8 AZ. If you do B cross A, coefficient of the first vector 4 and 2, because first vector here is B. Second vector, that is a vector 2 and 3 of AZ. This is 8 AZ. Very clearly they both are not equal. A cross B is not equal to B cross A, that's true. But if you append a minus sign here, minus of B cross A, 8 AZ will become minus AZ, minus 8 AZ. Then both will be equal. That means what? A cross B is equal to minus of B cross A. This is correct. Got the logic? Then what about the first statement? Can anyone tell me? Can anyone tell me what about the first statement? Is the first statement correct? Is the first statement correct? Is the first statement correct? Let us verify. Whether the first statement is correct or not. To do that, let me do minus B cross A. Minus B cross A is minus 4 minus 2. 2, 3 AZ. This is minus 8 AZ. That means what? The first statement is also correct. Most of the people get confused here. Both are correct actually. This is called property of determinant. What is property of determinant here? According to property of determinant, if K is a scalar, K is a scalar, A and B are two vectors, K into A cross B. That means this scalar quantity is multiplied to any one of these vectors in the cross product, then you can take it common. This is K into A cross B. It's called property of determinant. Similarly, A cross K into B is also equivalent to K into A cross B. That means a scalar or a constant, if it is multiplied to any one of the element in the cross product, that scalar or constant can be taken common. This is a property of determinant. And if that value is multiplied to both the vectors, you take 2 times common, that is k square of A cross B. Remember this. So here also we applied this property of determinant, and this k value is -1 here. K value is -1 here. That's why these both are equal. That -1 multiplied to B, or it is multiplied to both. When -1 is multiplied to B, you can take it common. So it's very simple logic. Property of determinant, both are equal. And we had seen the proof also, and had shown you that both will be equal. This is again one more frequently asked interview question. This is one more frequently asked interview question. Is it clear? Is it clear here? Next, does it obey distributive law? Sorry, let me see. First check associative, then distributive. Okay. Does it obey associative law? If it obeys associative law, A cross of B cross C must be equal to A cross B cross C. Are they equal? Are they equal? No, they are not. That is, it is not associative. Please verify. You only take any 3 vectors, and after the session you please verify whether they are equal or not. It is not associative. Next is distributive law. A cross of B plus C is equal to A cross B plus A cross C. Distributive law. Yes, it obeys. Please verify. Yes, it obeys. Please verify. So that's about dot product and cross product. Which laws they obey and all. Again, this is only just a small glimpse. You go to the playlist. In detailed explanation is given in the playlist. Then we had seen the most important del and its properties. Del and its properties. Del, also given as reverse of delta, is given as dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az plus dou by dou z of Az. As you can see, del is a vector in itself. Ax A by Az. This del is called as vector differential operator. It's a vector, and what does it do? It will do differentiation. Therefore, the del is called as vector differential operator, or it's also called as spatial derivative operator. Vector differential operator, spatial derivative operator, because it will do derivative with respect to space coordinates. Here in the Cartesian it is x, y, z. It's a special operator called as vector differential operator, spatial derivative operator. Properties of del, very, very important properties. Can anyone tell me properties of del, dear? Properties of del, anyone? New educators, as I told you, will take classes, dear. And Krishna, I told you, this Monday, transmission lines will start. So don't worry about transmission lines, dear. I told you, we'll start this Monday. And new educators, why they are not taking, they have some technical difficulties that we cannot explain here. Technical difficulties you have, okay? That will be sorted out. Most probably Archit sir will start control systems from tomorrow, and Sham sir will start networks. Is that clear, Krishna? Okay, dear. Huh? So, how are you preparing? How are you preparing? Had you attended the job opportunities session by the trio, Ram, Sham and Ken sir? In EMFT, how much you had completed, my dear friend? Krishna? In EMFT, how much you had completed? And today there is one more session at 9:30 p.m. by Ken sir, Ram sir and Sham sir. Probably from tomorrow, you can expect. There is a technical difficulty actually. They are all ready. They are all ready to take. There are some difficulties that we cannot explain here. Ken sir is trying to sort it out. They are new educators, no? First time until they launch on YouTube, they'll have some formalities to be completed. So that difficulties we are having. That's it. Once they start the first class, the flow will not stop. Already you can see that they are taking classes. Along with Ken sir. Today also 9:30 p.m. we have the session here. Properties of del. When del directly operated on a vector using the dot product, it is given as del dot A. It is read as divergence of A. It is read as divergence of A. Del is a vector, A is a vector, dot product of two vectors is scalar. So divergence of any vector is a scalar quantity. If this divergence is 0, A is said to be, A is called as divergence-less vector, which is not having divergence. Because its divergence is 0, you call it as divergence-less vector. A is called as divergence-less vector or solenoidal vector or solenoidal vector. If the divergence is positive, A is said to be source. The divergence is negative. It is called as sink. Again, so many practical examples are given in the playlist here. This is not that complete explanation that we are given. Please refer the playlist. Given so many examples here. One water body example also had given for better understanding of divergence. Similarly, del operated on a vector using a cross product given by del cross A is called as curl of A. Del is a vector, A is a vector, cross product of two vectors is a vector. Curl of any vector is a vector quantity. Curl gives orientation of A or rotation of A. If that rotation is 0, A is said to be irrotational vector. If the rotation is not equal to 0, A is called as rotational vector. Here again, some wonderful examples were given. Please refer the playlist. All those practical examples and understanding, because as I told you previously, it will take a lot of time to explain those examples again. So you can refer the playlist so that you get more clarity. And when del is directly operated on a scalar V, this is read as gradient of scalar V. Gradient of any scalar is a vector quantity. Practically saying, what are the examples? Just I'll give a glimpse of it. Del dot A is 0. A is called divergence-less vector. Example for this: del dot B is 0. Therefore, B is divergence-less vector. This is from Maxwell equation, non-existence of magnetic monopole. A magnetic monopole does not exist. Divergence is positive. Del dot D is equal to rho V. Gauss law. Sink. Del dot D is minus rho V from Gauss law. Charge is negative, then it is sink. Positive charge source, negative charge sink. These are examples from Gauss law. Gauss law for electrostatics, and this is Gauss law for magnetostatics. Non-existence of magnetic monopole is also known as Gauss law for magnetostatics, and this is Gauss law for electrostatics. Curl is zero, example. Curl is zero, example. Del cross E is zero. Static electric field is irrotational or conservative field. Del cross E is not equal to zero. Del cross A is not equal to zero. Example, del cross H is equal to J. Ampere's law. Gradient of any scalar is a vector. Example, E is equal to minus del V. V is electric potential, E is electric field intensity. See, all these properties are closely related to the subject again. That's why this topic, del and its properties, are very important. One second. Okay. Okay. Now, this was del and its properties. We went through vector identities. What were vector identities? First one, divergence of curl of any vector is zero. Second, curl of gradient of any scalar is zero. A is a vector and V is a scalar. Del dot AV is equal to A dot del V plus V into del dot A. As A dot B is equal to B dot A, del V is gradient of any scalar is a vector. So I can write this as del V dot A because A dot B is equal to B dot A. Dot product obeys commutative law. V into del dot A. Del cross AV. It's del V cross A. V into del cross A. Del dot A cross B is equal to B dot del cross A dot del cross B. Last one is a vector triple product A cross of B cross C B into A dot C, C into A dot B. It's called as back minus cab rule. It's called as back minus cab rule. These are vector identities. Again, only just a glimpse I had given. In detailed explanation, you can refer the playlist. With this, in basics, you finish elements of vector calculus. The second part of it, is coordinate system. Under coordinate system, let's see types of coordinate system. In types of coordinate system, we have Cartesian coordinate system, it is also called as rectangular coordinate system. Second one, cylindrical coordinate system. Also called as circular coordinate system. Third one is spherical coordinate system. Tell me dear, what are the coordinates here? What are the coordinates here? What are the coordinates here? Cartesian or rectangular coordinate system. Coordinates x, y, z. Cylindrical coordinate system, coordinates rho, phi, z. Spherical coordinate system, coordinates r, theta, phi. This Cartesian coordinate system, coordinates x, y, z, limits x from minus infinity to plus infinity, y from minus infinity to plus infinity, z is also from minus infinity to plus infinity. And how is x defined? X is defined as the shortest distance from YZ plane, a distance on x-axis, a distance parallel to x-axis. Similarly, y is defined as distance on y-axis, distance parallel to y-axis, a shortest distance from xz plane. Similarly, z is defined as the distance on z-axis or distance parallel to z-axis, shortest distance from xy plane. Similarly, cylindrical coordinate system, coordinates are rho, phi, z. Rho is the radius of the cylinder, it cannot be negative. Therefore, 0 to infinity. Phi is azimuthal angle. By 0 to 2 pi. It is angle from x-axis to rho. Again, in detailed explanation if you want. If you want in detail explanation, please refer the playlist here. Again, lot of concept is there in understanding why these limits are in this way. That everything I explained in the playlist here. Please refer the playlist. Why the limits are in this way, how they are defined, that I explained in the playlist, my dear friends. Please refer the playlist for in detail explanation of this. Spherical coordinates are theta, phi, are radius of the sphere 0 to infinity, theta co-altitude angle 0 to pi, phi azimuthal angle 0 to 2 pi. Again, why these limits are in this way I explained. Please refer the playlist. Types of coordinate system, their coordinates and their ranges, their definitions, their limits, explanation was given in the playlist. Just I'm giving an overview here. Then we went for point transformation. That is how to transform a point, one coordinate system to another coordinate system. How to transform a point from one coordinate system to another coordinate system. How to understand point transformation. Point transformation. Cartesian to cylindrical. Cartesian to cylindrical. X-axis, x-axis, y-axis, z-axis, horizon, Cartesian to cylindrical. If you consider a point P here in the xy plane, the distance from origin to this P is what? Radius of the cylinder, rho. Length in xy plane is rho, which is radius of the cylinder by definition. The distance from and angle from x-axis to rho is phi, azimuthal angle. If you see from top, you should not see this angular view, you should see from top. This rho will rotate, phi also rotates 360 degrees. Just like you have a cycle spoke, in cycle wheel you have spokes, this rho will rotate like that. You see from top, you see the angle from the top, projection from the top, it looks like this, like a wheel. The top of the cylinder which shows you the wheel, just like this. like this. You should see from top. If you see from top, this is rho and this is x-axis. This is x-axis. This angle is phi. This angle is phi. This rho can be here, 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 anywhere. Now you got the shape like a cycle spoke, am I right? So this is phi. Distance parallel to y-axis. This is y. Distance parallel to x-axis. This is x. Cartesian to cylindrical. X, y, z are known. I want rho, phi, z. Z no change. Z is z. This is opposite side. This is adjacent side. This is the projection falling at 90. Length opposite to the 90 degrees is hypotenuse. Hypotenuse square is side square plus side square. Therefore, rho square is x square plus y square. Rho is under root of x square plus y square. Tan phi is y by x. Phi is tan inverse of y by x. Phi is tan inverse of y by x. Now, cylindrical to Cartesian. Cylindrical to Cartesian. Cylindrical to Cartesian. Rho, phi, z are known. I want x, y, z. Z is z. If you take sin phi, sin phi is y by rho. Y is rho sin phi. If you take cos phi, it is x by rho. X is rho cos phi. X is rho cos phi. Y is rho sin phi. Z is z. Cartesian to cylindrical. Cylindrical to Cartesian conversion. Now, Cartesian to spherical. Later on, spherical to Cartesian. To do that, let me take the projection here. Point in YZ plane. The distance from origin to the point in YZ plane is R, radius of the sphere. So this is R. Angle made from R to the Z axis, by definition theta. And if this is rho, parallel length parallel length, this is also rho. This distance on z axis z, this is the projection, this is 90, this is hypotenuse, this is opposite, this is adjacent. Cartesian to spherical, r, theta, phi. Cartesian x, y, z are known. Applying Pythagoras, hypotenuse square, r square is side square, rho square plus z square. But from this equation we know that rho square is x square plus y square. From this you get r square is equal to x square plus y square plus z square. From this r is under root of x square plus y square plus z square. Is that clear? Is that clear? From this theta, tan inverse of opposite by adjacent, rho by z, but rho is cylindrical coordinate. Try to write it in Cartesian. Rho is under root of x square plus y square. Replace. Theta is tan inverse of rho is under root of x square plus y square by z. Phi is same, tan inverse of y by x, no change. That is Cartesian to spherical. Now spherical to Cartesian. Spherical to Cartesian. Spherical to Cartesian. I want x, y, z. You need not convert completely here. Phi is already spherical coordinate. Just write rho in terms of spherical coordinate. That will suffice. How to write from here? Sin theta is equal to opposite by hypotenuse, rho by r. Rho is r sin theta equivalent. Cylindrical coordinate equivalent. Rho is r sin theta. Just replace rho by r sin theta. X is rho cos phi, that is r sin theta cos phi. Y is rho sin phi, r sin theta sin phi. Similarly, if you apply cos theta here, adjacent side by hypotenuse is z by r. Z is r cos theta. This completes the conversion. Point transformation conversion. Any doubts? Let me know here. Any doubts? It's point transformation. And we are seeing unit vector relations. Unit vector relations gives us how the unit vectors in Cartesian coordinate system ax, ay, az, cylindrical coordinate system a rho, a phi, az, spherical coordinate system ar, a theta, a phi are interrelated. Again, dear, I think I took 2 hours on this. Took 2 hours of class on only unit vector relations. We got interrelation between all these unit vectors. Very important concept. Please go to the playlist. Please go to the playlist for in detailed explanation about unit vector relations. Then we are seeing the derivation for dl, ds and dv. And as I told you again, so much of discussion on this also. dl, ds, dv. Please refer the playlist dear. dl in Cartesian coordinate system is dx ax plus dy ay plus dz az. Why it is dx ax plus dy ay plus dz az? I had given explanation in the playlist. Please go through it. In cylindrical coordinate system, it is d rho a rho plus rho d phi a phi plus dz az. Again, why it is in this way and how to remember it very easily. The shortcuts I explained in the playlist. Please go through it. For spherical, dr ar, r d theta a theta, r sin theta d phi a phi. This is how you write dl in Cartesian, cylindrical and spherical coordinate system. Why you are writing in this way? I had given detailed explanation here. Please go through the playlist. Coming to ds, it is dy dz ax, dz dx ay, dx dy az. Similarly, in cylindrical, rho d phi dz a rho plus dz d rho a phi d rho rho d phi az. In spherical, r square sin theta d theta d phi ar. Here the coordinates are r theta phi, length dr, length r d theta, r sin theta d phi. R sin theta dr d phi is a theta, r dr d theta a phi. That is ds in Cartesian, cylindrical and spherical coordinate system. Similarly, dv is a volume, differential volume. dx dy dz, rho d rho d phi dz, r square sin theta dr d theta d phi. And if you integrate this over a volume, we get x into y into z, that is L into b into h, volume of the cube. And if you integrate this over a volume, you get the volume of the cylinder. I'll show you an example here. Volume here is triple integral dv, triple integral rho d phi dz. Rho is from 0 to infinity, phi 0 to 2 pi, z is 0 to h. Rho is rho square by 2. Integral 1d phi phi 0 to 2 pi 2 pi 1dz z0 to h pi rho square into h. The volume of the cylinder, area multiplied by height. For volume of the cylinder, this area, for example, this is of radius rho, this is of radius rho, then this area is pi rho square, this height h, the volume will become pi rho square h. Similarly, if you integrate this, volume V is triple integral of dV, triple integral r square sin theta dr d theta d phi. Sorry, 1 second. R is 0 to r here also. Because I consider a cylinder of radius rho, I must limit it to rho. Okay, fine. This 0 to r, theta 0 to pi, phi 0 to 2 pi. Volume is r cube by 3, 0 to r, minus cos theta 0 to pi, phi 0 to 2 pi, r cube by 3, cos theta pi to 0 into 2 pi. Cos 0 is 1, cos pi is minus 1. 1 minus or minus 1, 1 plus 1, 2. R cube by 3 into 2 into 2 pi. This is 4 by 3 pi r cube, volume of the sphere. Is it clear? And these equations you can write it as dl is equal to h1 du au plus h2 dv av h3 dw aw ds is h2 h3 dv dw au h1 h3 du dw av h1 h2 du dv aw and dv is h1 h2 h3 du dv dw. Have we got this? Take this table. Scaling factors. H1, H2, H3. Coordinate system. And parameters. coordinate system, Cartesian coordinate system, coordinates x, y, z. If it is length, scaling factor, you should write 1. I'll write it here. Cartesian coordinate system, coordinates x, y, z. Cylindrical coordinate system, rho, phi, z. If it is length, you should keep 1. Rho is length. Phi is angle. Keep its radius, rho. Z is length, keep it 1. Spherical, r, theta, phi. R is length, keep it 1. Theta is angle, keep it r. Phi is angle, keep it rho. But rho is r sin theta, equivalent. Spherical coordinate system does not understand rho. So r sin theta. Now using this table and these equations, substitute here, you will get these formulas. Please verify. Please verify now. Verify and tell me. Everyone verify and tell me. Substitute that. DL is H1 DU AU plus H2 DV AV plus H3 DW AW. Substitute H1 value 1 into DU DX, 1 into DX AX plus 1 into DY AY plus 1 into DZ AZ. What do you got? DL is equal to DX AX plus DY AY plus DZ AZ. Substitute the second one. H1 is 1. 1 into D rho A rho, DU is 0. AU is 0. 1 into D rho A rho plus H2 rho into DV F D phi AV A phi. Rho into d phi a phi plus 1 into dz az. So what do you got? 0 a rho plus rho d phi a phi plus dz az. Substitute the third one. 1 into dr ar plus r into d theta a theta plus r sin theta d phi a phi. What do you got? dr ar plus r d theta a theta plus r sin theta d phi a phi. You got dl in all the three coordinate systems, am I right? These formulas you got. Which formulas you got? This one. 1, 2, 3. Similarly, substitute for ds and check whether you are getting these formulas or not. Similarly, substitute for dv and check whether you are getting these formulas or not. Please verify now. Everyone verify. Do you all got that? So 9 formulas are reduced to 3 here. Similarly, if you write divergence of any given vector A, del dot A is given by 1 by H1, H2, H3, dou by dou U of H2, H3, AU, dou by dou V of H1, H3, AU, AV, dou by dou W of H1, H2, AW. This will be suitable for all the 3 coordinate systems now. Especially students find very much difficulty in writing divergence, curl and gradient in all the 3 coordinate system. So I am trying to reduce the difficulty by giving this formula. curl, rotation, 1 by h1, h2, h3, determinant of h1 AU, h2 AV, h3 AW, do by dou U, do by dou V, do by dou W, h1 AU, h2 AV, h3 AW. That's del cross A in all the three coordinate system. Similarly, if you take gradient of scalar k, otherwise let me write del first. Del is given as 1 by h1 dou by dou U of AU, 1 by h2 dou by dou V of AV, 1 by h3 dou by dou W of AW. That's del. If you take del or a scalar k, del k is 1 by h1 dou k by dou U, 1 by h2 dou k by dou V, 1 by h3 dou k by dou W. This is gradient of scalar k. Gradient of scalar is a vector quantity. Now if you take Laplacian here, del square of A can be written as del dot, one second, del square of k, del dot del k, gradient of scalar is a vector. Gradient of scalar is a vector. So I can write this as del dot, what is del k right here? 1 by h1 dou k by dou U of AU, 1 by h2 dou k by dou V of AV, 1 by h3 dou k by dou W of AW. That's del k. Now del k is a vector. Substituting del dot A. Now these are the coefficients which are equivalent to AU, AV, AW. So this is equivalent to del square k is equivalent to 1 by h1, h2, h3 dou by dou U, h2, h3. Now replace AU by 1 by h1 dou k by dou U plus dou by dou V, h1, h3 replace AV by 1 by h2 dou k by dou V plus dou by dou W, h1, h2 replace AW by 1 by h3 dou k by dou W. This is Laplacian. Okay, this is Laplacian. Is that clear? Everyone, is that clear? Yes. So with that, see what we have done in basics, elements of vector calculus and coordinate system. Then we went through static field theory. Just remember, 50 hours of content is there here. Just I am trying to revise in 1.5 hour. 1.5 hour I am trying to explain what we had dealt in module 1. But surely not possible to explain everything at any cost, because that is 50 hours content. Only just overview I am giving you, so that who are joining new to our channel, they understand what level of content is available with us. And static field theory, second part, static field theory. Static field theory, we have electrostatics, and magnetostatics. Under electrostatics, we have dealt with Coulomb's law. Electrostatics, we have dealt with Coulomb's law. Coulomb's law is a generalized law which explains about force between point charges. So we explained about Coulomb's law, this generalized law that governs electrostatics, and we have seen the applications of Coulomb's law, that is over line charge, surface charge and volume charge, and we derived the expressions for electric field intensity for each one of them. Through this, what we derived is from Coulomb's law, derive the force between the point charges Q1 Q2 by 4 pi epsilon naught r square AR, and hence from this we derived electric field intensity, which is force per unit charge. Electric field intensity given by Q by 4 pi epsilon naught r square into AR. And this equation also shows you why the positive charge is acting as a source, negative charge is acting as a sink. Keep a positive charge here. These distances are, electric flux lines are moving outwards like this along AR. If the positive source is acting like, the positive charge is acting like a source. Similarly, if you reverse the direction, negative charge if you keep here, minus AR, they all come in. If positive charge acts as source, negative acts as sink. Similarly, for line charge, we derived electric field intensity is rho L by 2 pi epsilon naught rho aero. Remember, dear, we all derived this, not directly we are given. So that's the reason we took 50 hours there. Every derivation we derived. For surface charge, is rho s by 2 epsilon naught an. We derived these things. From the playlist you can verify. This will be useful for engineering services. Then we went for Gauss law. Gauss law is a special law that governs electrostatics and can be applied only on Gaussian surfaces. What are Gaussian surfaces? Gaussian surfaces are those which are symmetric with respect to charge distribution. Gaussian surfaces are those which are symmetric with respect to charge distributions. Speaking about Gaussian surfaces, if you take point charge, the Gaussian surface is a sphere. It's symmetric with respect to charge, this point charge. Symmetric means if you stand here and one of your friend is standing here, both are at equal distance from this charge when you are standing on this surface. Therefore, this surface is said to be Gaussian surface. Similarly, for line charges, cylinder is a Gaussian surface. So, Gaussian surface, only when Gaussian surfaces are there, we can derive the Gauss law. Gauss law is derived over Gaussian surfaces. It says that psi is equal to charge enclosed. This is Gauss law in true form, and we had seen applications of it. Applications we had seen for point charge, line charge, surface charge and volume charge. All the derivations we have done, that will be useful for engineering services. Then we had seen electric potential, also called as EMF, electromotive force, which is voltage. We have seen relation between E and V. We derived E is equal to minus del V. These are the most important. These are the most important points. That we derived in electrostatics. Clear? Similarly, this is the most important points. Again, as I told you, it's a 50-hour playlist. Naturally, you cannot expect that we finish it off the 50-hour playlist revision in 1 or 2 hours. But just I'm giving a broad overview so that those that join new in the new to our channel can go through this playlist for their advantage. So in static field theory, we have electrostatics, and these are the main concepts we have dealt under electrostatics. Then we went for magnetostatics. Magnetostatics, the generalized law that governs magnetostatics, Biot-Savart law, which explains the magnetic field intensity due to current element, which you got it as dH is equal to IDL cross AR by 4 pi R square. H is line integral of IDL cross R by 4 pi R cube. That's the derivation. we've seen application over line current. It's Biot-Savart law. Generalized law that governs magnetostatics. Then we went for Ampere's law. The special law that governs magnetostatics can be applied only on Amperian paths. Ampere's law states that closed loop integral of H dot dl, circulation of H is equal to I enclosed. True form. True form. And Ampere's law can be applied only on Amperian paths. Just like Gauss law can be applied only on Gaussian surfaces, and Gaussian surfaces are those which are symmetric with respect to charge distribution. Similarly, Ampere's law can be applied only on Amperian paths. Amperian paths are symmetric with respect to current distribution. And we have seen applications of Ampere's law, very big derivations are there here. We have done that. That will be useful for engineering services. We took applications of Ampere's law over line current, surface current and volume current. Clear? In applications, we have seen line current, surface current and volume current. Just like we derived electric potential, in magnetostatics we derived scalar magnetic potential. Given by Vm. Given by Vm. Scalar magnetic potential given by Vm. It's also called as MMF. Magnetomotive force. Here this is electric potential is called as EMF. Electromotive force which is voltage. MMF is called as magnetomotive force which is current. And there is a problem here that MMF cannot be defined everywhere. Wherever there is sigma, MMF will fail. Why it will fail? I explained in the playlist. Please check out. Please check out the playlist. Why MMF will fail? I explained very clearly in the playlist. Please go through it. Failure of MMF. As MMF cannot be defined where sigma is not equal to 0 or where we have some finite conductivity, and it can be defined only in free space or vacuum, we defined one more potential called vector magnetic potential. We defined vector magnetic potential. It's given by A. It is related to B as relation between A and B. Just like relation between E and B, here relation between A and B given as del cross A is equal to B. See the similarities. Coulomb's law, general law, Biot-Savart law, general law, Gauss law, special law, Ampere's law, special law. This can be defined for Gaussian surfaces. This can be defined for Amperian path. Gaussian surface is symmetric with respect to charge distribution. Amperian path is symmetric with respect to charge distribution. Amperian path is symmetric with respect to current distribution. Here true form is psi is charge enclosed. Here true form is Circulation of H is equal to I enclosed. Here we have electric potential EMF. Here we have scalar magnetic potential MMF. Here it is voltage, here it is current. Here we got relation between E and V is minus del V. Here we got relation between A and B, which is del cross A is equal to B. Comparative study is very, very important. Then we are dealt with some common topics. Common topics of both electrostatics and magnetostatics. One is Poisson's and Laplace equations. Which are common for both electrostatics and magnetostatics. Boundary conditions. Work done and energy density. Work done and energy density and boundary conditions. And overall, combined electrostatics and magnetostatics, we derived Maxwell equations for static fields. That is synopsis of this entire static field theory. Then in electrostatics, we derived capacitors and types. Magnetostatics, we have derived inductors and types. Clear? Poisson's and Laplace. Poisson's and Laplace equations. Electric field and for magnetic field. We know from Gauss law, del dot D is equal to rho V. D is epsilon naught E. Del dot epsilon naught E is equal to rho V. From this, del dot E is equal to rho V by epsilon naught. But we know from relation between E and V, E is minus del V. Del dot minus del V is rho V by epsilon naught. This for a inhomogeneous medium. For a homogeneous medium, del square V is equal to minus rho V by epsilon naught. It's called Poisson's equation. It's called Poisson's equation. In the special case, in Poisson's equation, when charge is 0, you get Laplace equation. So make charge 0. Charge 0 means rho V is equal to 0. You get del square V is equal to 0. This is Laplace equation. And del square is called Laplacian operator. Del square is called Laplacian operator. If you take for magnetic fields, take for magnetic field from Ampere law, Del cross H is equal to J. B is equal to mu naught H. From this del cross B by mu naught is J. Implies del cross B is equal to mu naught J. We know del cross A is equal to B. Substitute. Del cross A is mu naught J. This is the form A cross of B cross C. Back minus cap rule, B into A dot C minus C into A dot B. Here we have del cross A, B into del of del dot A minus A into del dot del. Del cross A, del of del dot A minus del square A. Substitute. Del of del dot A minus del square A is equal to mu naught J. Now here, what we apply is Gauss transformation. What does it say is, as we know, del dot B is equal to 0. B is solenoidal field, and we also know that del cross A is equal to B. Orientation of A is B, and such B divergence is 0. Resultant divergence is 0, indicates that source divergence is also 0. This is called Gauss transformation. So by applying Gauss transformation, as we know del dot B is 0, from Gauss transformation del dot A is also 0. Substituting, you get del square A is equal to minus mu naught J. Poisson's equation. Keeping charge 0, here charge is J, J is 0. Del square A is equal to 0. Laplace equation. These are Poisson's and Laplace equation for electric field and magnetic field. This one. Is that clear? Okay. Work done and energy density. Work done and energy density. Work done and energy density. Again, for electric fields, Work done, WE, is 1 by 2 volume integral of d dot E dV, 1 by 2 volume integral of epsilon naught E square dV, 1 by 2 volume integral of d square by epsilon naught dV. Because we know d is equal to epsilon naught E. Work done in magnetic field, 1 by 2 volume integral of B dot H dV, 1 by 2 volume integral of mu naught H square dV, 1 by 2 volume integral of B square by mu naught dV. This is for work done, and you know how they are related. If this is work done here, small part of this is energy density. Derivative of work done is energy density. Integration of energy density is work done. So if you do derivative for this, otherwise I'll write simply work done. Work done formula for both electric and magnetic fields. Energy density, the derivative of work done, given by small w. Which is derivative of work done, 1 by 2 d dot E, one by 2 d dot E, 1 by 2 epsilon naught E square, d square by 2 epsilon naught, energy density in magnetic field. Derivative of work done, 1 by 2 B dot H, one by 2 mu naught H square, B square by 2 mu naught. This work done and energy density, both electric and magnetic fields. This one. Then the boundary conditions. Any doubts so far? Any doubts so far? Next is boundary conditions. First one, dielectric, dielectric boundary conditions. First one, ET1 is equal to ET2. tangential component of electric field intensity is continuous across the boundary of discontinuity. What is the word statement here? What is the word statement for this? The word statement for the boundary condition is tangential component of electric field is continuous across the boundary of discontinuity. That means when the field is moving from one region to another region, crossing the boundary, the tangential component of electric field does not vary. It will be same. That means if you know the tangential component of electric field intensity of your source electric field, you need not calculate for the destination because it is not going to change. That's why boundary conditions are very important. If you know boundary conditions and if you know the component on your side of the field, you can estimate the field on the other side of the region without going there. That's why boundary conditions plays a very important role. And the first boundary condition is ET1 is equal to ET2. Tangential component of electric field intensity is continuous across the boundary of discontinuity. Now you may ask me, sir, how you got this? Please refer playlist here. It's a very big topic, 2-hour topic it is. 2 hours I explained on this. Please refer the playlist. The complete derivation was done. That will be useful for engineering services. And so many number of questions. All previous year questions, many special questions, practice questions, whatnot. We covered so many concepts there. 2 hours exclusively only theory we covered. 2 or 3 hours practice we had done on questions. All that content is available in the playlist. Please go through it. So ET1 is equal to ET2. Tangential component of electric field is continuous across the boundary of discontinuity. It is continuously it is unconditionally continuous. Second one, dN2 minus dN1 is equal to rho s, where rho s is the surface charge density, whereas rho s is the surface charge that is deliberately placed on the boundary. This implies dN1 is equal to dN2 if and only if the rho s is 0. That means normal component of electric flux density is continuous across the boundary of discontinuity if and only if rho s is 0. It is conditionally continuous because it is continuous only when the condition is satisfied, that is rho s is 0. It is conditionally continuous. Third one, HD2 minus HD1 is equal to K cross AN, vector notation, scalar notation. HD2 minus HD1 is equal to K, magnitude. Implies HD1 is equal to HD2 if and only if K is 0. Tangential component of magnetic field intensity is continuous or does not change across the boundary of discontinuity if and only if K is 0, where K is the surface current that is deliberately placed on the boundary. ST1 is equal to ST2. Fourth one, Bn1 is equal to Bn2. Normal component of magnetic flux density is continuous across the boundary of discontinuity. It is unconditionally continuous. Now if you take dielectric conductor boundary condition, that means one of the dielectric is now replaced by conductor or a perfect conductor. Then what are the boundary conditions? As we all know that in a perfect conductor, field components cannot exist. Now you may ask me, sir, why they don't exist? Please refer playlist. Please refer playlist. I explained the concept why field cannot exist in a perfect conductor. Please refer the playlist for the same. As it cannot exist, this value will become 0. No ET1, only ET. E tan is equal to 0 implies that tangential component of electric field on the surface of perfect conductor is 0. Tangential component of electric field on the surface of perfect conductor is 0. This is the first one. Second one, you make dn1 0, only dn will be there. D normal is equal to rho s. Normal component of electric flux density is equal to surface charge density, where rho s is the surface, where rho s is the charge that is placed on the conductor. Similarly, H tan is equal to K cross An. Relation between H tan and K. Similarly, B normal is equal to 0. B normal is equal to 0. And again, this is also very rarely someone explains you dielectric conductor boundary conditions, my dear friends. Please make a good note of it. Please make a good note of it. Very, very important. Thank you, Archit sir. Good morning, sir. How are you? Those are dielectric conductor boundary conditions. Finally, these are boundary conditions. Capacitors and types, inductors and types. Capacitors and types. Parallel plate capacitor. Capacitance epsilon A by D. Epsilon is the dielectric material, A is the area of each plate and D is the distance between them. Coaxial cable capacitor. Cylindrical capacitor. Two pi epsilon L by ln of B by A. Again, if you are having any doubt, sir, how you are getting these numbers, these derivations, these equations, please go to the playlist. I derived all this. So derivations are there, not direct formulas, but we derived and we have done numerous number of previous year question papers and the practice questions also. Next, spherical capacitor. C is 4 pi epsilon 1 by A minus 1 by B. A is the radius of the inner sphere, B is the radius of the outer sphere. If the radius of the outer sphere is made to infinity, then the inner sphere is called isolated sphere. And the capacitance for isolated sphere is 4 pi epsilon A. A is the radius of the isolated sphere. Good joke. Students are asking you, sir, when you will be live on YouTube. Students are asking this question continuously. What should I answer? For inductors, solenoid, inductance, n square mu A by D. For a toroid, inductance n square mu A by 2 pi r. R is the radius of the toroid. Magnetic field intensity, Ni by L or Ni by D. Toroid, Ni by 2 pi r. So this is about capacitors and inductors. Capacitors and types, inductors and types. So overall, from this second part, static field theory, the final conclusion will be Maxwell equation for static fields. Maxwell equations for static fields. Maxwell equations for static fields. Equation number integral form, differential form, and source. Equation 1, integral form, closed surface integral d dot ds is equal to volume integral of rho v dv. Again, all this we derived here. Please refer the playlist. Please refer the playlist. We derived all this. Differential form delta t is equal to rho v. Source, Gauss law for electric fields. Second, closed loop integral of E dot dl is 0. Implies del cross E is equal to 0. Source, conservative property of electric field. Third one, closed loop integral of h dot dl is equal to surface integral of j dot ds. Integral form. Differential form del cross h is equal to j. Source, Ampere's law. Fourth, Closed surface integral B dot ds is 0. So del dot B is equal to 0. Differential form del dot B is 0. Source Gauss law for magnetic fields. Also called as non-existence of magnetic monopole. The magnetic monopole does not exist. So all this we had derived here, which makes us Maxwell equations for static fields. This will make Maxwell equations for static fields. This is static field theory. If you boil down completely the concept of static field theory, this will be tabulated into Maxwell equation. That's it. You can say the summary of static fields in short is this: Maxwell equations. Everything is interrelated to Maxwell equations only. From Maxwell equations for static fields we change them to derive Maxwell equations for time varying fields. From Maxwell equations for time varying fields, we combine them to get Helmholtz equations. Helmholtz equations are wave equations. From there you get wave propagation. Then you analyze how waves are propagating through different media. Everything is interlinked from here. Clear? So everything is interlinked here, dear. Let us see this one by one. Let us see these Maxwell equations. Maxwell first equation for static fields is from Gauss law. Gauss law states that the amount of flux cut by any closed surface is equal to the charge enclosed by the surface. This is true form. Now if you try to equate electric flux density, defined as electric flux per unit surface area, unit coulomb per meter square. If you consider a small surface area ds, flux is d psi e, that is d psi e by ds, implies d psi e is equal to d into ds. This is called the scalar notation. This is called the scalar notation. D psi e is equal to d into ds is called the scalar notation. Now if you write it in the vector notation, d is a vector, ds is a vector, then d dot ds is d psi e. This is called vector notation. This is called vector notation. From this, d psi e is equal to d dot ds psi e, surface integral of d dot ds. Psi e is closed surface integral of d dot ds is equal to charge enclosed. How to write charge enclosed? If you take rho v, volume charge density, total charge by total volume, given by coulomb per meter cube. Consider small volume dV, the charge associated is dq. From this, dq is rho v dV. Q is volume integral of rho v dV. Replacing, this is volume integral of rho v dV. Closed surface integral of d dot ds is equal to volume integral of rho v dV. This is called integral form of Maxwell first equation. Applying divergence on LHS, what is divergence theorem? According to divergence theorem, closed surface integral of A dot ds is equal to volume integral of del dot A dV. If A is any energy source, let A be any light source for suppose. And what does it mean is the amount of light that is kept in this closed surface. Amount of light that is kept in this closed surface is equal to the amount of light that is diverging or spreading in this volume. As simple as that, if you keep more light, you will get more spreading. Am I right? Applying the divergence here on the LHS, then closed surface integral of d dot ds is volume integral of del dot d dv is volume integral of rho v dv. Implies del dot d is equal to rho v. It implies differential form of or point form of Maxwell's second equation. Differential or point form of Maxwell's second equation. Differential form or point form of Maxwell first equation, Gauss law. So that is what is the derivation for this fellow. How we got this conservative property of electric field? Conservative property of electric field. How we got that? Conservative property of electric field. We know work done is related to force and displacement as work done is equal to force into displacement. W is equal to F dot L, where F is the electric force given by Q into E. Force acting on this charged particle Q in the presence of electric field E. Therefore, W is equal to Q into E dot L. W is Q into E dot L. If you consider a small work done dW, Q into E dot dl, it results in small displacement. What does it mean? Work done by this charge in the presence of electric field, or work done in moving this charge in the presence of electric field by value of dl is given by dw. From this total work done is Q into integral of E dot dl or a path L. Now if you consider an assumption that external agent is doing the work, then total work done will become negative minus Q into integral of E dot dl. Now if you want electric potential, we know electric potential is work done per unit charge divided by Q minus line integral of E dot dl. This is called relation between V and E. This is called relation between V and E. From relation between V and E, we got V is equal to minus line integral of E dot dl. This for a path having loop L. Now if you consider this loop is having two ends, A and B, then VAB, which is VA minus VB, will be equal to minus integral. VAB means moving from B to A, lower limit B to A, E dot dl. E dot dl. Now if you extend this up to C, again dear, I'm telling you, so much of derivation is there here. I'm just trying to cut short. Please go through the playlist for in detailed explanations, okay? If you extend it up to C, then you get VAC, which is VA minus VC. Up to D, VAD, VA minus VD. Close it, VA minus VA, 0. It implies that when you close this loop, the V value will become 0. 0 is equal to minus closed loop integral of E dot dl. Implies closed loop integral of E dot dl is 0. This is called integral form of Maxwell's second equation. Applying Stokes on it. What is Stokes theorem? Closed loop integral of A dot dl is surface integral of del cross A dot ds. If A is any energy source like light, the amount of light that is kept on this loop is equal to the amount of light that is circulating in this area. As simple as that. So applying the Stokes on LHS, closed loop integral of E dot dl is surface integral of del cross E dot ds is 0. Implies del cross E is 0. Implies del cross E is 0. Differential form or point form of Maxwell's second equation implies that electrostatic field is irrotational field. It cannot be rotated. That is this. We got this. Clear? That is Ampere's law. Ampere's law. Tell me dear, what is Ampere's law? Anyone? True form of Ampere's law, anyone? Come to Ampere's law, circulation of H, magnetic field intensity is equal to current enclosed, true form. You know, current density J is equal to current per unit surface area, ampere per meter square. Consider small surface area ds, current is di. From this di is equal to J into ds, scalar notation. Vector notation, dA is equal to J dot ds. I is surface integral of J dot ds. Relation between I and J. Open surface. Consider closed surface. I is closed surface integral of J dot ds. For closed surface. Substituting closed loop integral of H dot dl is equal to surface integral of J dot ds. Integral form of Maxwell third equation. Applying Stokes on it. Closed loop integral of h dot dl is equal to surface integral of del cross h dot ds is equal to surface integral of j dot ds. Removing the integral, del cross h is equal to j. Differential form of Maxwell third equation, indicating that static magnetic field is not irrotational. It is a rotational field. Of course, static magnetic field will always rotate. If you have a straight current carrying conductor, according to Faraday's right hand thumb rule, if the right hand thumb indicates the direction of flow of current, fingers encircling indicates magnetic field. So that is this. Third one. Fourth one, Gauss law for magnetic fields or non-existence of magnetic monopole. Gauss law for magnetic fields. Non-existence of magnetic monopole. A magnetic monopole does not exist. That means if you take a permanent magnet, it contains north pole and south pole. If you break them into two, again subsequently you get north pole and south pole. Magnetic flux lines will move from north pole to south pole. Outside the magnet. Inside the magnet they move from south pole to north pole, forming closed loop. This uniform magnetic flux psi m. So this permanent magnet is generating psi m and consuming psi m. And how they are related? Magnetic flux density B is equal to magnetic flux per unit surface area, Weber per meter square, or Tesla, the great Nikola Tesla, after the name of great Nikola Tesla. Unit is Tesla. If you consider small surface area ds, flux is d psi m. This implies d psi m is equal to B into ds. Scalar notation. D psi m is B dot ds. Psi m is surface integral of B dot ds. Relation between flux and flux density. But here you know the net flux is 0. Substituting closed surface integral B dot ds is 0 because flux psi m is 0 here. This is called integral form of Maxwell fourth equation. Applying divergence on it, closed surface integral of B dot ds is volume integral of del dot B dV is 0, implies del dot B is equal to 0. This is the differential form. Differential form of Maxwell fourth equation, indicating that B is divergenceless field. B is solenoidal field, indicating that there are no sources and sinks for magnetic fields. These are the conclusions that you derive from this equation, and these are the four Maxwell equations. These are Maxwell equations for static fields. In this, we modify this equation and this equation. This equation is modified by Faraday's law. This equation is modified by inconsistency of Ampere's law, or also called as Maxwell contribution, which will generate Maxwell equations for time varying fields and which will conclude Module 1. This is a brief synopsis of Module 1, dear. As because this is a concept through question series, all the concepts regarding this Module 1 has been explained. Please go through the playlist. Please go through the playlist for further understanding of this, because 50 hours of content is there on this. So it is not possible for me to explain in 2 or 3 hours. But those who want to revise, this class will be useful for them. They can revise all the concepts at a go, like a super fast revision. Okay. One second here. If you take Maxwell equations, time varying fields, Maxwell equations for time varying fields, equation number integral form, differential form, and source. Remember, dear, dot products won't change. Dot products are same for both static and time varying fields. Okay? They won't change. Equation number 1, same. Closed surface integral of d dot ds is equal to volume integral of rho v dv. Differential form del dot d is equal to rho v. Source, Gauss law for electric fields. Same, no change. Fourth equation, closed surface integral of b dot ds is 0. Del dot b is equal to 0. Gauss law for magnetic fields, no change. Second and third will change. Second, closed loop integral of v dot dl. Closed integral of v dot dl is equal to surface integral of minus dou b by dou t dot ds. Differential form del cross E is equal to minus dou b by dou t. Source, Faraday's law. Third equation, closed loop integral of h dot dl is equal to surface integral of j plus jd dot ds, where j is conduction current density sigma e, jd is displacement current density dou d by dou t. Differential form del cross h is equal to j plus jd sigma e plus dou d by dou t. Source, Maxwell contribution also called as inconsistency of Ampere's law. Let us see one by one Faraday's law and Maxwell contribution and conclude this class. Okay. Faraday's law. According to the statement of Faraday's law, the induced EMF within any closed path is equal to the rate of change of flux linkage. Lambda is called flux linkage given by n into psi m. N is number of turns. But later, scientist Heinrich Friedrich Emil Lenz said that the induced EMF will always oppose the flux produced it and introduce a negative sign here, from which you got VEMF is equal to minus d lambda by dt. Substituting VEMF is equal to minus lambda is n psi m minus n d psi m by dt. N is number of turns. If you consider a straight conductor, n is 1. VEMF is equal to minus d psi m by dt. Now here VEMF is closed loop integral of V dot dl. Remember two things here. One, general relation between V and E is V is minus line integral of V dot dl. This is general relation. Two changes I had made here. I removed this minus because if you remember, the minus is because of my assumption that an external agent is doing the work. Here in time varying field, no external agent is acting here. So I can make this plus or I can remove the minus. And if I close the loop, this value won't become 0 because only static electric field is conservative, not time varying electric field. It won't become 0, so I can keep the closed loop. So trying to keep these two changes here. And we also know that psi m is surface integral of B dot ds. Just before in the previous derivation I derived relation between magnetic flux and magnetic flux density. Psi m is surface integral of B dot ds. Substituting closed loop integral of E dot dl is equal to minus dou by dou t of surface integral of B dot ds. Implies closed loop integral of E dot dl is surface integral of minus dou b by dou t dot ds. This is called integral form. Applying Stokes on it, closed loop integral of E dot dl is surface integral of del cross E dot ds is equal to surface integral of minus dou b by dou t dot ds. Substituting, we get del cross E is equal to minus dou b by dou t. Del cross E is equal to minus dou b by dou t. This is differential form. You can check out here. Integral form and differential form. Faraday's law. Next one, the last one, which is Maxwell contribution or inconsistency of Ampere's law. Before we go for inconsistency of Ampere's law, let me explain conservative property of charge. What is conservative property of charge, dear? According to conservative property of charge, the rate of decrease of charge means minus dq by dt. Rate of change means dq by dt. Rate of decrease means minus dq by dt. Rate of decrease of charge within a closed loop is equal to the current flowing through that loop. 1 second here. Conservative property of charge, conservative property of charge. The rate of decrease of charge within a closed volume is equal to the net outgoing current. But we know it's a natural phenomenon here. Rate of decrease of charge is equal to net outgoing current. If you take your cell phone, if you use the cell phone continuously, charge will decrease. The rate of decrease of charge in that battery, that is volume, is equal to net outgoing current, the current that is passing into the phone. It's a natural phenomena. And how Q is related? Q is related as volume integral of rho v dv, relation between Q and rho v. And how I out is related? I is equal to closed surface integral of J dot ds. Both of them I derived previously, so I am not deriving again. So from this, It is minus d by dt of volume integral of rho v dv is equal to closed surface integral of j dot ds. This implies write RHS onto the LHS side. Closed surface integral of j dot ds is equal to volume integral of minus dou rho v by dou t of dv. Applying divergence on LHS, closed surface integral of j dot ds is volume integral of del dot j dv is equal to volume integral of minus dou rho v by dou t of dv. Removing the volume integral, we got del dot j is equal to minus dou rho v by dou t. And this cannot be wrong. This cannot go wrong because it is from a natural phenomena called conservative property of charge. And this is called continuity equation. This equation is called continuity equation. Therefore, continuity equation is from conservative property of charge and it cannot go wrong. Why I am telling this? Because in Maxwell contribution, this plays a very important role. Maxwell contribution is also called as inconsistency of Ampere's law, because Maxwell has proved that Ampere is inconsistent. I mean, Ampere's law is inconsistent. Okay, how he proved it? Simple, he took Maxwell equation del cross H is equal to J. He had done divergence on both sides. Del dot del cross H is equal to del dot J. He had done divergence on both sides. From vector identities, divergence of curl of any vector is 0. So from this he got del dot J is equal to 0. But what he argumented is, according to continuity equation, del dot J must be equal to minus dou rho v by dou t, which is a contradiction now. It is an ambiguity. And this cannot be wrong. Continuity equation is from a natural phenomena called conservative property of charge. So he said that something is wrong in this Ampere's law only. And he coined the term called displacement current. Current that can fly in air. Now it is not a wonder that if I say current can fly in air, because you are getting signal to your cell phone, you know that the current or the signal is flying through air. The current associated with this EM wave is a displacement current. It is very easy to convince you on this day. But imagine 170 years back in 1850, someone is saying that current can fly in air and there is a time varying field. No one believed it. That's the problem. And what he had done mathematically is, he took this Ampere's law, del cross H is equal to J, and he had added a term called JD, which is called displacement current. Along with conduction current, he added displacement current. Then he had done divergence on both sides. Del dot del cross H is equal to del dot of J plus JD. From vector identities, divergence of curl of any vector is 0. 0 is equal to del dot J plus JD. Implies del dot J plus del dot JD is equal to 0. Implies del dot JD is equal to minus del dot J. Implies del dot JD is equal to del dot J from continuity equation. It is minus dou rho v by dou t. Minus of minus plus dou rho v by dou t. Implies del dot JD is equal to dou by dou t of rho v is del dot d. Del dot JD is del dot dou d by dou t. Implies JD is equal to dou d by dou t. Comparing it, we got displacement current is equal to dou d by dou t. Therefore, the modified equation will become del cross H is equal to J sigma E conduction current density plus JD displacement current density dou d by dou t. From here we got this equation. Done. And if you see these modified equations, the two modified equations are del cross E is equal to minus dou B by dou t. Del cross H is equal to sigma E plus dou d by dou t. If you see these two equations carefully, orientation of electric field depends on time varying magnetic field. Orientation of magnetic field depends on time varying electric field. We got interdependency between electric field and magnetic field, which is a necessary condition for waves. If you combine these two equations, we get Helmholtz equations. Helmholtz equations are nothing but wave equations. They'll tell you how waves will propagate. We'll get del square E is equal to gamma square E. And del square H is equal to gamma square H. Del square E is equal to gamma square E. And del square H is equal to gamma square H. These are Helmholtz equations, solving which we get solutions for E and H, where gamma is under root of j omega mu sigma minus omega square mu epsilon. Gamma is called propagation constant, which is alpha plus j beta. Alpha is attenuation constant, beta is phase shift constant. Of course, once we go into waves, we explain all this. But I want to tell you the continuity here. In the next session, we'll do problems on this. From these concepts, we'll try to do some more problems on this. Okay? Till then, go through all these concepts carefully, which are very, very important. And thank you all for joining. Have a great day.